The video on me doing the problem with paper and pencil. I want to go through checking it, right? For one thing I want to do is go through that I graph the problem. What am I graphing? 3 divided by sine x plus 4, and on an interval from 0 to 2 pi. Now certainly I'm showing the outlying edges from 0 to 2 pi, but right now this is where the 0 would be. Over here, this is where the 2 pi is, all right? So if you recall, we found 2 critical points over there, and the 2 critical points we found were x equals pi over 2. Let me display that for you. And the other critical point we found was x equals 3 pi over 2. All right, so I displayed both of those. Now what's happening at those points? Well, we have a minimum over here, and that minimum occurs at pi over 2. And then there's a maximum over here, and that occurs at 3 pi over 2. Again, we did this paper and pencil. It wasn't a difficult one, but the critical points, reading it, pi over 2, 3 pi over 2. Local maximum occurs at 3 pi over 2, and the local minimum occurs at pi over 2. And then over here, we got the second derivative, and we found 2 critical points for that as well. All right. Now, granted, I had to correct my notes, and that happens sometimes. A lot of times we type these things up. No one's actually reading them, by the way, which is surprising. But and they've been around a long time. But the errors get in there. I don't read it either. I kind of type it up. I write a piece of paper. I type it up. Sometimes I type it incorrectly, or I make mistakes. But I want to go through this. Let me get rid of the min-maxes. And I had claimed there was points of inflection here. And what's that going to be? X equals pi plus the arc sine of root 6 minus 2. All right. Now, someone says point of inflection, what is that? That's where concavity changes. So I see like concave up here, and then I'm seeing it's going concave down over here. I also claimed there was another point of inflection, and that occurred at 2 pi. I typed that in for you. 2 pi minus the arc sine of root 6 minus 2. And that's over here. Now, granted, this is where it's concave down here. Over here, it's concave up. And we're just going from 0 to 2 pi. Now, certainly, let's just go over and review. Determine intervals where it's concave up. When kind of looking at it, we just review those numbers. It requires some, certainly some understanding of trigonometry to do that. But some students have it, some students don't. Some students haven't really spent enough time in this. So anyway, concave up from 0. By the way, 0, it's still concave up at 0. And then, of course, remember, it stopped being concave up when we reached the pi plus the arc sine of the root 6 minus 2. And then it went concave down from pi plus the arc sine of root 6 minus 2 all the way up to here. And this was 2 pi minus the arc sine of root 6 minus 2. And it continued to be concave. I'm not sure. Let me get to what I was saying. And it was concave up. Let me say I said that right. Concave down. Yeah, I did that. Concave down. Yeah. And then concave up from that same location up to 2 pi. Now, certainly when I say 2 pi, it's still concave up at 2 pi, and that's why it's included. So I'll post the video. Hopefully you watch the videos that we're giving you to watch, right? Particularly if you need help with this. Thank you so much for paying attention to this.